Hey guys, alright, so here is part 3 of 7D. Like I said, this one can be kind of hard. Hopefully you guys have been practicing some of the sides and angles practice I've been providing because it helps. The more practice you have with this, the easier it gets, I promise. So, just like in this world, you gotta practice, which is what I hope everyone's doing at home during this whole lockdown situation. So in part three is not anything that we haven't done already. If you guys have already done 7D part A with the missing angles, and then 7D part 2 with the missing sides, this is the same thing. The only thing it's using now is word problems. And there are going to be a couple new words that we're going to look at. So here are the two new words. We're going to talk about the angle of elevation. The angle of elevation is when someone is positioned below and looking up. So for instance, if you're on the ground like this person here in this photo, looking up at the top of the tower, it kind of creates an angle of elevation because you look at your horizontal eyesight to what you're looking at, then you have to look up at it. So it's kind of about looking straight, then up. So you're looking at the angle from here to here. How much is that angle? That would be your angle of elevation. So the opposite one is the angle of depression. The angle of depression, not to be mistaken with the angel of depression, which is Rolando. Thank you. I had to give you a shout out while I'm doing this. So when someone is positioned above and looking down. So that would be your angle of depression. Remember, if you're sad, you're usually looking this way, then looking down because you're depressed, right? So you're looking straight, then down. And I have two cats here. All right, if they walk in the photo, they walk in the photo. Anyways, so for instance, here's this fighter jet with the angle of depression. It's about where its line of sight is versus where it's shooting down from. Now, what you'll start to notice is that the angle of, hi Sophia, please don't walk across. Thank you. You're a good girl. So we have our angle of depression here, right? It's going to be the same as your angle of elevation because there's a term that we haven't talked about it, but it's about the alternative interior angles. Essentially what it states is that if you have two parallel lines and a line through it, it means that this angle will be the same as this angle, and this angle will be the same as this angle. Kind of like that. So the opposite angles will be the same every time if the two lines are parallel. So that's how that works. Now let's get your art skills together. For instance, this first example says, Dario is hunting with a bow and arrow, and he aims at a bird in the sky. His angle of elevation is 71. Draw a diagram that represents this. So I'm going to draw Dario, and he's got a bow. I know, well, let's make this bow a little bit better because he's supposed to be shooting up with it, right? All right, bow and arrow. And he aims at a bird in the sky. So doot, 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 doot. Here's a bird. This is going to be my terrible bird. This is where Heidi and Stephanie would be like, Mr. Moore, that doesn't look like a bird. Yeah, I know. It's okay. It doesn't have to be perfect. Not everyone's perfect in this world. Anyways, talking about non-perfect things, we have an angle of elevation right here, which is 71 degrees. There you go. That's our photo. Here's another one. Alex is on top of a garage with a parade goes by. His angle of depression is 54. So let's draw a garage. Here's its door. Usually doors kind of have something like that. It's a door. It's a garage. Just deal with it. So here's Alex. He's just chilling, hanging out. Now, he has an angle of depression. Remember, you have to kind of look forward like this and then down to find your angle of depression. So this would be the angle of depression, which would be 54 degrees. Here's a parade going by. People like walking by, waving, going, hey. I don't know, that person looks like they're old. It's a parade, just parade. There we go. Anyways, so if this one is 54, then we also know that this angle here would also be 54 degrees. That's how angle of depression works. If you guys forget, here's some cool drawings about it so that we can kind of see it. Notice how the angle of depression and angle of elevation are going to be the same thing. All right, let's move on. All right, here we have a 6-meter long ladder leaning against a building. Okay, so let's draw ourselves a ladder leaning against a building. Here's a ladder. And it's leaning against the building. Here's the building. Something like that. It has an angle of elevation, which is 60 degrees. So remember, your angle of elevation would be about right here, and that should be about 60 degrees. Okay. What do we say? Oh, it's a 6-meter long ladder. That's important part. A 6-meter long ladder. So the ladder is 6. What it wants to know is how far up the ladder does the wall reach? Well, we're looking at the height of the wall, right? So then if you want to kind of turn this into a triangle, turn it into a right triangle, looks something like this, where we know the 6 would be the ladder, which was this part. We have a right angle here. We don't know the height of the wall, but we do know that right here is 60 degrees. So then how do we find this? Well, we have to use trigonometry. First things first is label. Well, they gave us this x, which is your opposite, and this 6, which is your hypotenuse. And if you forgot, write out SOHCAHTOA. So obviously if we use opposite and hypotenuse, that's a sine equation. So it will be sine of how many degrees are we working with? 60. Why am I saying 60? Because it said it was a 60-degree angle of elevation. 60 equals the opposite over the hypotenuse. Now, if you're in the last video, you can kind of skip this step because it's just going to turn to sine of 60 is equal to our opposite, which is x over our hypotenuse, which is 6. This side, we're going to put it over 1. And then, because we have this ratio now, we're going to cross multiply. So let's cross multiply. 60, sine of 60 times 6, and x times 1. So then let's write that out. We would have 60 times, or sorry, not 60, 6 times the sine of 60, which is equal to x times 1, which is just x. X is by itself, which is perfect. So now we just put this in our calculator. We're just going to say 60 times sine of 60, like that. Hit enter. 5 point something. 5 point, was it 196? Oh, the 6 would round this 9 up into a 10, and 10 plus a 1 would give a 20, so it would just be 5.2 is equal to x. Like that. And that's it. Let's look at one more. All right, Elise is standing on top of a 50-foot building. So let's draw Elise standing on a building. She is not going to jump. Don't jump, Elise. Here she is. All right, she sees her friend Molly below. Let's draw Molly. Here's Molly. Molly has a ponytail. She's like, don't jump. All right, if the angle of depression from Elise to Molly is 48 degrees, remember, if you draw your angle of depression, we have to draw straight out. Then we're going to draw to Molly. So we know that this is 48 degrees. 48 degrees. That means this spot here is also going to be 48 degrees. Remember, she's standing on top of a 50-foot building. How tall is this building? 50 feet. Excuse me. It wants to know how far away is Molly standing from the base of the building. Essentially, they're asking how far is she standing away from the bottom here. Well, if you don't like looking at it in this context, we can kind of draw it as a right triangle. So let's do it. Something like this. Where this side was 50, this side was x, and right here was about 48. Now, if you're wondering why this part isn't 48, because remember, that was kind of this spot here. This spot and this spot are not the same. And that's a different rule that we're not going to talk about today. So that's why we had to use angle depression. You have to kind of bounce to the inside corner like that, the alternative interior corner. Now let's label. This side is the adjacent, this side is the opposite. Okay, well, which function uses adjacent and opposite? Tangent. So this is going to be tangent of 48 degrees is equal to the opposite divided by the adjacent. Now, once again, you can skip this step if you're quick and just go right into the next part, which is tangent of 48, which is equal to the opposite, which is 50, over the adjacent, which is x. This we're going to put over 1. Already, you should know that, oh, if x is on the bottom, we're going to have to divide here. But we're still going to cross multiply. So let's do that. Well, x times tan of 48 is going to be x times tan of 48, which is equal to 50 times 1. 50 times 1 is 50. Well, if you watched the last video, what do we do in this situation? Well, we have x times tan, and the opposite of multiplying by tan is to divide by tan. Not just to one side, but to both sides. Tan of 48. Okay. Then all you have to do is put that in your calculator. So let's do that, because tan of 48 divided by tan of 48 will cancel. So let's do control divide. 50 divided by trig, hit tan of 40. Whoops, didn't work at all. There we go. Down, trig, tan of 48. And there we go. We get about the height of that. She's about 45.02 feet away. And that's that. Last thing I wanted to show you guys, I want you guys to finish any of these problems I haven't completed, is this one about, let's look at a skateboard. This one's going to be a missing angle problem. So, a skateboard ramp at a local park is 30 feet long. Okay, when we talk about the ramp, we're going to talk about the long part here. The long part of the ramp is going to be about 30 feet long, with a height about 5 feet. So we know height goes up and down, so this is about 5 feet. I know it's not drawn on the scale. It's a long ramp. What is the angle of elevation of the ramp? So if we kind of draw this ramp here, we don't know the angle of elevation. This is our question mark, or X if you'd like to put that instead. Well, determine the angle of elevation. This should be easy. Watch. Because if we're just trying to figure this out, we could figure out that this side, actually I didn't need to draw that twice at all, really. So we'll just label it. What is this, 5 feet? Well, this is your opposite. Excuse me. This 30 feet is your hypotenuse. What function uses opposite and hypotenuse? Sine does. But remember, if we're trying to find a missing angle, we have to use sine inverse. You only have to use the -1 when you're trying to find missing angles. So this would be sine of the opposite divided by the hypotenuse. So let's plug this in. Sine of -1, our opposite is 5, sorry, that's feet, over 30. And if you put this in your calculator, which we'll do right here, we're going to go trig, go down to sine inverse of 5 divided by 30. And if you want, you can close it up. Doesn't matter. We get about 9.59. So that'd be 9.59 degrees. And that would be your answer. So that's how this video concludes. There are some more questions that I'd like you guys to try to go on and work with. I have all the ink copies of this uploaded as well. If you have more questions, please send me messages and let me know what you're confused on. Thanks, and hope you guys are staying safe and healthy.